عسلامة العباد الكل. باش نبداو توا. عسلامة ومرحبا بكم العباد الكل في الورك شوب الليلي نتاعنا. اليوم باش نحكيو على داتا ساينس. في البروغرام نتاعنا نتاع اليوم باش نعملو انتروداكسيون صغيرة، بعديكا باش نعملو انتروداكسيون للداتا ساينس وباش نشوفو لي كيستيون نتاعكم ابروبو لي سوجي هذا، بعديكا باش نذكرو لي لاب نتاعنا، بعديكا باش ناخدو بوز نتاع 5 مينوت هكاكا، ومن بعديكا باش نبداو في الخدمة نتاع لي لاب نتاعنا. تعملوا مزيا العباد الكل، تسكروا الميكرو نتاعكم ديورون السيسيون هذيا، واللي عنده سؤال ان شاء الله نجمو نجاوبوا عليه في البريك ولا في السيسيون نتاع كيستيون ريبونس. انجوي العباد الكل وسؤالي بالفعل.
So, hello everyone. I'm gonna kinda translate my friend's words because, as you know, we have here foreign guests. Shout out to you guys and welcome here among us in this hopefully successful session about data science. Please turn off your microphones to make it easier to hear each other. And if you have any questions, you can write them down below in the chat. Hopefully, you're gonna have a good experience and learn a lot of new things about data science thanks to the amazing Jonathan Hart. So welcome here, Jonathan Hart. Thank you for being here with us and for giving us such an opportunity. So the session is all yours now. Welcome.
Awesome. All right, I'm going to show you my face just for a little bit so you know who you're hearing from, and then I'll hide it again later. All right, can everybody see and hear me? Hi.
Hey.
Yeah, we can see you.
Cool. So yeah, a bit about me. My name is Jonathan Hart. I'm a final year student at the University of Cape Town in South Africa, and I am an outgoing DSE lead. So for 2019-2020, I was running a DSE in Cape Town, and now I am kind of, an alumni. So I'm going to do talks like this at all sorts of DSEs to try and support the community. So more on me, I'm studying a degree called Business Science Analytics, and it's quite a strange title, but essentially it's a lot of business and it's a lot of statistics, and it's preparing me for a degree a career or future in data science. So over the past 4 years, I've been doing a bunch of business courses in things like finance, accounting, strategic thinking, people management, those sort of things. And I've also done a lot of mathematics, a lot of stats, and a lot of computer science. So it's been really interesting, and I have a personal passion for data science. I've taken part in hackathons and competitions. I've done some online courses, and I've done some internships, which I'll talk about later. So yeah, that's a bit about me, and I'm going to share my screen with you now, hide my face, and we're going to jump ahead straight into the session. But first, thank you so much to everybody that is here today, and thank you to Bahassan and his team for inviting me and giving me the privilege of presenting to you today. It's going to be a really fun session.
No, thank you. Thank you so much.
So I'm just going to share my screen now, and let me know when you can see it.
We can see it right now. It's okay.
Awesome. Great. Yeah, so it says Jono Hart there. Jono is kind of a nickname for me. I've grown quite fond of it, but you can call me whatever you want. So today we're going to be covering 3 main things. I'm going to start with an introduction to data science. I'm then going to introduce machine learning because that's what our lab is going to be all about. And then I'm going to obviously do this lab with you. At many stages throughout the presentation, I will stop and look at questions. So if you have any questions at any stage, just put them in the chat, or when I ask for questions, you can also speak up. Don't be shy. We're all friends here today. We're all students. It's going to be a great session. So the first question that's on most of your minds is, what is data science? And for this, I'm going to give you a short answer, a long answer, and then a helpful answer. So the short answer is, data science is a science of analyzing data. Now, this is technically correct, but it's also a bit too simplistic. We might want to ask, how do you analyze data? Why should you analyze data? Which leads me to the long answer. And it's overwhelming. Here you can see that the kind of blue section with all of these tools and all of these disciplines. We see things like artificial intelligence, machine learning, we see business intelligence, we see statistics. So while this answer kind of tells you what data science is in a big picture idea, it isn't very helpful. The helpful answer is data science is the scientific process of transforming typically large amounts of data into information to guide decision making. And this speaks to the core of what data science is. In today's world, there's a massive volume of data, some of it helpful, some of it not helpful. We have some structured data like medical records and business ledgers and financial databases, but we also have unstructured data like social media posts, noisy stock prices, and all sorts of other things. So we need to take this big data and we need to find out the patterns in it, and we need to use those patterns to make better decisions. And this requires expertise, and that's what data science is. So now, if you look back at this image, it makes a lot more sense. We see all sorts of data, but only some of it is useful. And then we need to apply all sorts of tools and techniques to this useful data to extract information. And then we need to use that information to help organizations or businesses make better decisions. So there you go. It's a multidisciplinary field aimed at making data useful to us. And it requires business expertise, programming skill, a bit of knowledge of statistics, but most importantly, it requires an analytical mind. And you don't have to be good at all of these things already to be a data scientist. You just need to have a passion and a drive to make data useful. And then you'll pick up the skills along the way. So at this stage, I'm just going to stop and ask if there are any questions. All right, I can see no questions in the chat, but if you do have a question, you can speak up and ask it. Cool. For now, I'm going to proceed, assuming that there are no questions yet. So I've given you that helpful answer, but now I just want to take a brief detour and talk about some of my experience. So I did an internship at a company called Data Profit last year, and they title themselves as machine learning specialists, and they work in the industrial sector. So they work with lots of foundries and car companies and processing plants and all those things. And they are data scientists. So when I kind of explain the data science process to you now, I'm going to use my experience with them as reference. And they're a very cool company. In fact, they've just received $6 million in funding to fuel their expansion plans. And if you look carefully at this nice photo, I'm just going to get the tool again, you can see me. This photo was taken when I was interning there. So the data science process or the data science pipeline looks like this. We have data gathering, analytics, and execution. And analytics can be broken down into descriptive analytics, predictive analytics, and prescriptive analytics. So let me talk to you about a bit of these. So we always start with data gathering as a data scientist. And this involves working with the client and finding out the challenge that they want solved. Based on this, you will request certain data from them, or maybe help them collect the data. And once you've done this, it's usually a lot of data. So you need to get it in the right format, and you need to clean it up and work through it. So if, let's say, you're trying to help out a factory, and they want to see how to optimize their assembly line, you might start collecting all sorts of information about the assembly line. And some of it won't be useful. Some of it might just be dates, some of it might just be IDs, but there could be lots of useful information too. So you take a massive amount of data and you choose, which columns do we want to take, which features do we want to talk about. And then once you've done that, you also have to clean it up, because sometimes there could be missing data. So maybe for a month, they had power outages, so they couldn't get all the data on those days. You need to make sure that the data that you're going to pass through your systems later on is ready and prepared in the way you need it to be. So referencing my internship at Data Profit, this is what they would often do. They'd go to a factory, and the factory would say that we want to collect all sorts of data on our different parts in the process. And Data Profit would put lots of sensors around and collect data every single day for months. Then they would take that data and they would clean it up, like I just said, to make sure that there's no missing stuff. And then they would take that to the next step, which is analytics. So once the data is ready, like I said, you start the analytics process. And this comes in 3 stages. There's first descriptive analytics. And this is when you're summarizing and visualizing the data. So this could be things like making plots to explore the relationship between variables. This could be looking to see the shape of the data and whether there are any distributions that might fit the data. So here you see, that could be a histogram of data, and you're fitting some kind of curve to it. It could just be bar plots to compare the data. It could be plots to look for correlation between variables, or could be maybe seeing how the variables change over time, like an increasing trend here. So you do this to find out kind of more intuitively which data is useless. And you also want to check out, maybe some of these bits of data can be combined into new data or new features. And sometimes this is all the client wants. So sometimes a client just wants to see, can you tell us whether our stuff is improving over time or whether it's going down over time? But more often than not, they actually want you to take that data and start making predictions. And this leads us to the next bit, predictive analytics. So like I said, more often you want to make predictions off of this data. And that's where a lot of these statistical learning techniques come in, the things that we're going to be talking about today, like machine learning. So this is when you want to identify patterns or relationships in the data. And these patterns might be very useful in making classifications or predictions. So it could be things like looking for clusters in the data, different groups that you can segment. It might be taking a trend like this and seeing if you can actually predict it into the future. It might be looking for a line of best fit, like with regression problems. It could be looking at images and trying to classify different objects in images. So that's what this whole part is. And tools like machine learning or modeling come in handy here. So predictive analytics is basically useful for taking the data you've gathered and using it to make predictions or to better understand relationships. And that leads to the last part of analytics, which is prescriptive analytics. And this is where you've used these patterns and these predictions to help make decisions, to prescribe optimal settings. So at Data Profit, like I said, they would gather all the data from their client. They would then take this data and pass it through a lot of their models, which more often than not were machine learning models. And then they would analyze the results of these models and use this to write reports, very nice reports that they would then take to the client and say, this is what you need to change. So as a data scientist, you need to understand what your predictions mean and then write reports detailing what the client would need to do next. And this leads us to that last step, which is execution. So this is where you communicate your findings very clearly to the client and you tell them what the next steps should be. This is going to help them. This is also about helping them execute those steps and making sure that they follow through. And this is also getting feedback from them and monitoring it so that next time you can also improve your approach. So that's why this is an iterative process. You start with execution, but then you go back to square one. This could be with the same client or with a new client, because there's always new data to take into account, to pass through, to perform analytics on, and then to execute. And so as you can see, as a data scientist, you have a lot of roles. You're not just building a machine learning model. Often you need to talk to your client and understand their business needs. You need to think, what data do I actually need to collect for this? And then you need to clean that data. Then you're going to try a bunch of different models and see which ones help make the best predictions. You'll use those predictions to make recommendations to the client and you'll communicate it. And then you'll monitor it, you'll get feedback, and you'll start the process again. It's a very, very interesting and useful and exciting pipeline. And I hope that I've given you a better understanding of what data scientists do. So at this stage, I'm going to stop and just check if there are any questions. So far, I don't see any questions in the chat, but if anybody would like to ask one in the chat now or maybe speak up, you're welcome to do so. All right, so far, people say it's quite clear. I'm very happy to hear that. That's very good news. It sounds like you're following on very well. Cool. Back to the presentation. So now we move on to the next section, which is machine learning. And this is very important because the lab today we're going to be doing is in machine learning, or was on machine learning. So here's a definition, and I'm going to read it to you, and then I want you to maybe tell me who this definition's from. So this definition says machine learning is a field that is basically collecting lots and lots of data in order to create models and algorithms, and then data scientists can take those models and start applying them to all kinds of problems. Does anybody know who said that? You can say in the chat. Take a guess. Come on, don't be shy. All right. I was hoping some of you might. Okay, I see a question actually. So thanks, Mohammed, for asking if it's Elon Musk. People often say that whenever I've done a presentation like this before. I'll answer that in a second, but there's a question. And the question says, do we always have to do all types of analytics? So I guess, like I said, there's descriptive, predictive, and prescriptive. And the short answer is no, you don't always have to do all types. It does depend on the client. So like I said, sometimes people just want you to do descriptive analytics. A lot of clients don't know how to take their data and put it into a graph format and look at plots and stuff, and they don't know what those plots mean. So sometimes you might just be consulting for somebody, and when you're consulting, you might just tell them that based on these graphs, this means that this is what's happening at your factory, and that's enough for them. But a lot of clients would want you to go the step further and say, okay, we see now that we're performing badly based on your data analysis. Can you see how we could maybe change that? And that's when you would do predictive analytics. You would make predictions, and you can, from those predictions, you can often find out through your models if you changed one thing, what the impact would be. So maybe you change one thing and that's going to improve conditions at the factory. So you would then do the predictive analytics, and then you do the prescriptive analytics where you say, this is what you need to do. So definitely, you don't always have to do all types, but as a data scientist, it's useful to know how to do them all. And if you're doing an internship or you're an entry-level data scientist, you might only be doing one thing for some time, but hopefully you'll get enough experience with all of it. So back to the idea of Elon Musk. Yeah, so this could be Elon Musk, it could be Bill Gates, it could be any specialist, but actually this little quote here was written by a machine. So I went to a website called Talk to Transformer, and I put in the prompt. I said, machine learning is, and I generated a response. And it gave me the definition you just saw. And this isn't finding a definition online. This is the machine actually typing out sentences and then building onto those sentences. And this is because it's trained itself on hundreds of thousands of documents about machine learning. So you can see it starts by giving that definition. Then it starts saying a bit of rubbish, like, I actually started as a data scientist and then as a research scientist, and now I'm kind of in the middle again. So sometimes, it makes perfect English sense, but it doesn't make sense in the context of asking for a definition for machine learning. But still, it's very impressive. So I just wanted to show that as an example of what machine learning is capable of. You can generate text, and it's quite scary because if somebody reads that and they think maybe Elon Musk wrote this, and we're all smart people here, then that means millions and millions of people could be fooled by news or articles written by machines. And that's both exciting, but also quite scary. So now I'm going to give you, I guess, a better definition for machine learning. And this definition says, machine learning are algorithms that improve themselves through statistical learning methods. And that's really what machine learning is. And some examples of that, and obviously I'm sure you're all familiar with neural networks or have heard the word before, but other examples are things just like linear regression or tree-based methods or clustering and much, much, much more. And there's a distinction that people often, don't get. They often think that machine learning and artificial intelligence are the same thing, but they're not. We can think of artificial intelligence as any intelligent behavior coming from machines. So even when you say to Siri, call my parents, or Google Assistant, call my parents, and it makes that phone call, that's not machine learning being used, but it still seems intelligent. Or when robotic arms in a factory build a shoe, that's something that usually humans would only be able to do. So artificial intelligence is any intelligent behavior coming from a computer. Even just, when you create a profile on a website and it says welcome and then it says your name, that's something intelligent, right? Because humans call you by your name. So that's artificial intelligence. And machine learning is a part of that. It's a subset of that. So machine learning, like I just said, is the instance where these algorithms actually improve themselves over time through statistical learning methods. So Siri is a combination of machine learning and other types of kind of intelligent behavior. Siri doesn't need to learn how to access your contacts and call somebody called dad or call somebody called mother. It's just been told to do that. But it also can, recognize your voice, which is machine learning. And then there's also this question of what's the difference between machine learning and deep learning. And deep learning is a type of machine learning where you've got a very kind of dense network, lots and lots and lots of layers to your model. So things like a simple linear regression aren't deep learning, but they are machine learning. And even a neural network isn't always deep learning. But when it has lots of layers and lots of networks, then it is deep learning. And the one we'll be building today in the lab is an example of a deep neural network. So here I'm going to do something fun. There's this game called Quick Draw, and it's going to be a nice way to illustrate why machine learning differs from other kind of intelligent things. So I hope you can still see my screen. I'm just going to play this game. Please forgive my drawings. They might not be great. But essentially, Quick Draw is going to ask me to draw things, and then the algorithm is going to recognize what I'm drawing. So let's draw. First thing is an ear. I'm going to try this my best. Maybe we can say that that is what an ear looked like.
Oh, I know. It's ear.
It already recognized ear. Short monster. This might be difficult. I'm going to try and draw maybe a scary face.
Or volcano. Or person. Or yoga. I see flamingo.
No, I'm not great at drawing monsters.
I see stop sign.
How do I... Maybe I give it some wings.
I have no clue what you're drawing.
Okay, it doesn't know what I'm drawing. That's fine.
Sorry, I couldn't get it.
I think I can do a blackberry a bit better. Hopefully not the blackberry phone.
Or moon. Or flying saucer. Or mouse. I see and. Or shoe. Or camouflage. Or teapot. Oh, I know. It's blackberry.
It recognized that as a blackberry. Let's try and do a map.
I see square.
So maybe we'll have a continent.
Oh, I know. It's map.
It recognized that as a map. And let's try a trombone. I don't actually know what a trombone looks like. Maybe
I
it's
see line. Or leg.
like
Or
a...
marker. Or axe. Or water slide. Or harp. I see book.
No, I can't draw a
I
trombone.
see notebook. Or necklace. I see computer. Or flag.
Okay, well, that one's a fail, but that's all right.
Sorry, I couldn't get it.
This one I can do. Sword, all right.
I see marker. Or drill. Or pants. Or diving board. Or mushroom. Oh, I know. It's sword.
Look more like a knife. But there you go. 3 of the 6 things I drew it recognized. And I didn't draw things very well. My ear looked more like a balloon. My map could have been anything, and my sword looked more like a knife. But it was able to recognize these things. But how? Through machine learning. And this is where it's important to make the distinction between a rule-based approach and a machine learning approach. So a lot of the algorithms that we've created or that you might create in your degrees or in your life are rule-based algorithms. You kind of say, if this happens, this should happen. And that's often very useful. Like when I said, you know, a website recognizes your name, it might just say, you know, if the person's name, if they've typed in this name, then return this name to them. So you can do those kind of functions just with a simple set of rules. But you can't really do that with images. So you look at, you know, all these images of apples and you think, could we really give a set of rules that could determine all of these apples, even though they're all different shapes? You might say, okay, if it doesn't have a stem, it's not an apple. But as you can see, some of these apples don't really have clear stems, but they've still been recognized as an apple. This one does, it has a, you know, a chunk bitten out of it, but you still recognize it as an apple. And imagine you're trying to draw a square. With rules, you might say, if it has all sides that are equal, it's a square. But if I drew a square that had one side a bit shorter than the others, but it still looked like a square, a rules-based approach wouldn't work, but a machine learning one would. And that's because machine learning doesn't, you know, learn off of rules. It just learns from picking up patterns and trends. And trying to describe images would take millions and millions and millions of lines of rules and still might not work. But a machine learning thing can very quickly learn from examples. So that's the difference between rules-based and machine learning. And I want to just do an exercise with all of you where I ask you, what is the best approach to use, rules-based or machine learning? So this is a chance for people to engage in the chat. So for this problem of alphabetizing a list of song titles, would you recommend a rules-based approach or machine learning-based approach? You tell me. Okay, so far I've got 2 people saying rules-based, but we've got 35 people here. Come on, everyone. Nice. Okay, so 3 people said rules-based, and that is correct, sure. We don't need machine learning to alphabetize a list of song titles. We just need to give it some simple rules, such as if you get 2 words, you say, look at the first letter, and if this first letter comes before the other first letter in the alphabet, put that one first. And maybe if 2 words start with the same first letter, you then look at the next letter. So just through a few loops and conditionals and rules, we can get that. We don't need to apply any machine learning. What about this problem? ranking web search results. Is it a rules-based or machine learning approach? What would be best here? So I'm seeing some people say machine learning. Most people say machine learning, and I've got one person saying rules-based. The answer to this one is actually both. And this is because lots of the programs we commonly use are a combination of rules-based and machine learning. So with ranking web results, Google, for example, has an indexing algorithm, and this will just crawl around looking for things that have the tags that you've searched in. But then we also know that there's a degree of personalization where the algorithm actually knows you as a user and will tailor your search results based on who you are. So if myself and Belhassan were to search Tunisia, we'd both get different results, because even though all of the searches that it finds will be related to Tunisia because of the rules-based, for me, it might give hotels, and for Belhassan, it might give a restaurant nearby, because it knows that I'm a foreign visitor and that Belhassan is a resident. So the kind of customization and personalizing comes from machine learning, but the actual, just searching for the topic in the first place could be rules-based. Here's another example. Predicting housing prices based on location. Rules-based or machine learning? All right, so here everybody said machine learning, and that's absolutely correct. In this situation, it would be very difficult to find rules that could apply to every single location ever in the world. You might have two suburbs, and in some suburbs it might be more important, maybe the altitude of the house. In some suburbs it might be more important the number of rooms. But there's no single rule for houses that applies to every country in the world, whereas machine learning could learn patterns for different regions and could learn which factors are most important. So definitely machine learning would be the most suitable one here. What about processing online payments? So we've got some people saying both. We've got some people saying rules only. Rules, both, rules, RB, RB. Nice, I'm liking the engagement. I'm glad that everybody's taking part now. So this one, in all honesty, rules-based would be the best approach, because processing online payments is quite a simple, step by step. The person will put in their details, they'll press a button, that will be confirmed, but with some bank, and then the transaction is done. You have to think, is there a situation here where it could be different depending on the person, and an algorithm would have to learn over time, or can this just be done with kind of concrete rules that will never change? And in all honesty, with processing online payments, it would just be rules-based. And what about classifying an object in a photo? This one you all have to get. Nice. Perfect. That's the correct answer. Like we saw with quick draw, it would be impossible to try and describe objects with a set of rules. And even if you describe one image with a set of rules, it won't apply to all. So if you're trying to classify or identify cats, cats have different, sizes, different length of ears. Some of them have fur, some of them don't have fur. So you wouldn't be able to, just find a set of rules that will apply to every single cat. And sometimes it could be a cat at a different angle, or just half of a cat's face, those kind of things. So machine learning is definitely more suitable. So yeah, that is a recap of this distinction. So both of them have their benefits. In a rules-based approach, the rules are defined, and the improvements just come from the algorithm. So I gave a very bad algorithm for alphabetizing song titles earlier. I'm sure there are far better ones online. And machine learning, you're learning patterns from data, and improvements can come from additional data. So if we train identifying cats off of 3 cats, then it might only be able to identify cats that look similar to those 3. But if we train off 1 million, it might be able to identify even cats it's never seen before. So yes, each has its benefits. At this stage, I'm going to open the floor to a few more questions. And remember, if you have any questions, between these question sessions, you can always just put them in the chat and I'll scroll around and try and find them. But so far, so good. Everyone seems to be following. So now we're going to move on to the lab. So I'll go back to presenting the slides, because then you get a better view of what we're seeing. So this is the overview of the lab on Quick Labs, and I'm sure you've all seen this, or you will when you go onto the site. And I'm going to explain all of the different terms that you see here, just so that there's a better understanding. But this lab is going to be using TensorFlow 2 to train a model, both locally and on the AI platform. And then you're going to use the AI platform to do online predictions. And what this model is going to be doing is going to be predicting income category of a person using a certain data set. So let's go into that. What are we building in this case? We're going to be building a classification model to predict income categories. So you're going to be taking in some data that's, ideally being cleaned and everything by the data scientist. So, and we're going to be doing that kind of just that predictive analytics step. We're going to be passing it through a neural network, and it's going to give us an output for each observation in the data. It's going to classify it as either less than 50,000 or greater than 50,000 for the income of these people. Yeah. So this is a classification model. Often with neural networks, you're doing regression or classification. Regression is when you're predicting continuous values. So if it was just saying predict income, so 47,000, 63,000, that'll be regression. But in this case, it's either less than 50 or greater than 50. So it's a classification model. And these are neural networks that can take in any type of input, and it will assign it to one of several predetermined labels, such as cat or dog, or 0 or 1, or in this case, less than 50, greater than 50. And it doesn't have to be binary. It could be red car, yellow car, blue car. It could be dozens and dozens. It could be, identifying a type of animal. But in this case, like I said, we're predicting whether a person would have had less than or equal to or greater than $50,000 of income in a year. And this is not the only technique we could use for this problem. Lots of classification can be done with logistic regression, classification trees, models such as support vector machines. And then as a data scientist, you would learn the strengths and weaknesses of each of these, and you'd learn when to apply them, and you'd learn to apply the most appropriate one. In fact, a neural network might actually be overkill for this problem. We might be dealing, I don't actually know how many data points we're dealing with, but this seems like a pretty simple classification, and I'm sure something like logistic regression could perform far faster and maybe as well. So we would often train multiple models on the same data, and then we would compare their predictive accuracy, and we'd also compare their interpretability. And what I mean by interpretability is, after you've done this thing, does the model tell you what the relationships are between the inputs and that classification? So does somebody's age help determine their income category? And neural networks are often quite bad at telling us these relationships, but they're very good at making predictions. So as a data scientist, you need to weigh up, you need to weigh up, do we want something that performs well and predicts well, but is very bad with explaining things, or do we want something that balances both of those? So I see some questions here. There's a question, what is TensorFlow? I'm going to explain that now. There's also a question, are we going to do this locally in Colab? We're going to be doing it in Google Quick Labs. Yes, and thanks for answering, giving an explanation of what TensorFlow is. So let's go back to the presentation. So I've explained what we're going to be building here, and I'm just going to talk to you about the data we get. So we're getting a bunch of different variables on people in America from the census data set. So we'll get things such as the age, which is, I guess, numeric. It could be 7, 8, 9, 55. We're getting their working class. And this is a category. So some examples from the data are self-employed, privately employed, unemployed, working for state government, those kind of things. We get information on education, which is also categorical. So it says, did they get a high school education as their highest education? Did they get a bachelor's degree? Marital status, occupation, sex, race, and so on. So those are all the inputs that we want to use to predict output. So for every single observation, so for every single person, we're going to be getting all of these things on them as well as what the income was. And our model is going to try and find patterns in that, so that on unseen new data where we don't have the income, we can predict the income with some degree of accuracy. The AI platform we're going to be using is the kind of Google Cloud AI platform. And it's not only used for training and predicting, it has all sorts of different tasks and uses. And as a data scientist, it helps manage the entire data pipeline. You can do tasks such as labeling as well. And some of these models that we're going to be using in the real world, they train for hours and hours, and they can be very time consuming and costly to use on your own computers. If you're training off millions of images on your laptop, it might take a long time, or it might not even be able to do it. But on the Google AI platform, you can use a GPU in the cloud. You can have multiple processors do it. So it just ends up being very time and cost effective. And it's good to get familiar with a platform like this. And then back to the question of what TensorFlow is. TensorFlow is an open source library used for a range of maths and machine learning related programming. It's currently owned by Google, who bought it a few years ago, and it's mainly managed by the Google Brain team. So as much as I could have spent a lot of time today going into the mathematics and statistics behind all the machine learning, the nice thing about TensorFlow is that you don't need to know what's going on behind the scenes. You just need to know how to put the pieces of the model together. TensorFlow will do all the rest. And then the AI platform will do the heavy lifting on the cloud, like I just said. So as a data scientist, it makes your job a lot easier when you can use the cloud and when you can use very, very well optimized kind of libraries like TensorFlow instead of having to create your own machine learning algorithms. So yeah, we're going to move on to the lab now. Before we do that, we'll just make sure everyone's set up with the lab, and we'll also take a brief break and take some questions. So at this stage, does anybody have any questions based on the introduction to data science, the introduction to machine learning? And don't worry if you missed out or some of the slides went by quite fast. I'll be sharing the slides with the DSE ISI team, and they will make sure to send it out to whoever needs it. Do we have any questions? Cool. So as far as I'm aware, information was sent out with the steps to create a quick lab account and also to get your free trial for a month, which will allow you to do the lab. Has anybody here not gotten those steps and not set up an account on Quick Labs? We have a bit of time to make sure everybody's on the same page before we proceed. All right, so if you have got everything set up, then the next thing we're going to be doing is, okay, so Pratik has not got an account on Quick Lab yet. So you can quickly go and create an account. You can use your Gmail, whatever, but you are going to have to follow some steps, and it will take, I think, 5 to 10 minutes to get it up and running. So maybe one of the members of the team can send the steps to you so that you can get set up. We'll be starting just after, well, I guess 5 p.m. We'll be starting in about 10-15 minutes on the lab. So just everyone else that's got their account set up, you can go and take a break. And those of you who haven't got it set up, I think one of the team members will get in touch with you and you can sort that out. But what you should be looking at in 10 minutes time is something like this. On the AI the lab will be called AI Platform Quick Start. You'll have your account set up with a monthly subscription based on the code you'll be getting, and we'll be ready to start the lab. So I'll see you all in 15 minutes, and good luck getting set up.
Thank you, Sia.
So Pratik, you don't want to start the lab yet, but if you click Start Lab, there should be an option to use subscription. Don't click that, but if it says use subscription, that means that you've got it working and means that you're ready to use it for free. It's also nice because if you can't, for whatever reason, complete the lab today, you've got a month to do it as many times as you want and other ones. And you can get badges for doing all of these quests, and that'll help with your developer profile. So Pratik and Viral, when you have got it all set up, just tell us and then we'll end off the break.
Nasser وهاشم. Okay.
So Miriam, to answer your question, or your response on ML and AI. So artificial intelligence is any intelligent behavior that we see from computers or machines. Machine learning is an example of it. So it's part of AI, but not all of it. So lots of kind of examples of AI aren't uses of machine learning. I'll put the name of the lab we'll be doing. It's called AI Platform Quick Start. If you search that one, you'll find it. It's you'll see it's 1 hour long. But Virel, I'm glad that you have your setup done. Well done for sorting all of that out in a few minutes. Great. So Balhassan, shall we proceed with the lab?
I think everything is okay. Everyone has have his quick labs free access.
Well, it seems Virel doesn't have credits, so perhaps some of the steps weren't followed properly. We are going to have to start with the lab now, but you can follow along and you'll still be able to redo the lab and have access to it afterwards just by following the steps again. You can try as many times as you need to. So just stay and watch today and listen in, and then you can try it on your own in the future. But for everybody else, I'm going to share my screen now again, and we will get going with the lab. Thank you for understanding. Nice. I believe you can all see my screen now.
Yeah, it's all clear.
Great. So here we are on the AI platform. It says 1 hour, but it probably won't take us an hour. It's actually quite quick. Most of this lab is just running some code and understanding what the code does. So when we run the lines of code, I will explain what's going on, and you can also ask any questions. So I'll stop every now and then to take some questions, because it can be a bit faster at times. So when you're all ready, we click Start Lab, and we click Use Subscription. There we go. The timer is going down now. So scroll down to Setup. Actually, no, go further down to Launch AI Platform Notebooks. So if everybody is following, the first thing we're going to do is we're going to press Open Google Console. That is going to take us to a sign-in thing. And you can see here I have lots of accounts. But we want to actually use another account. So we're not going to be signing in with your usual account. What you're going to be signing in with is this username that's given you over here. So where it says username, there's a thing here for me. It says student03 on and on and on. And you're going to copy that. You want to copy that to your clipboard. And you want to use that as your email account and say next. And then when it asks you for your password, you want to go back, and again, there's something for you to copy for password. You're going to copy that and put that in and say next. And if you've done that correctly, you have to accept some terms, which we don't need to read. Just say confirm here. You don't need to protect the account because it's a temporary account that we only have for 1 hour. And now we should be taken to the Google Cloud Platform. While that loads, is everybody following, and has everybody gotten to the Google Cloud Platform? You can just say yes in the chat or give a thumbs up. Great, great, great. Okay. Not yet, but you'll get there. Nice, nice. Okay, cool. So you can see the time is still going, and we're going to be moving back and forth between this tab and the Google platform. So it says, welcome student. You have to agree to the terms of service. You can choose your country. Don't worry about email updates. Just choose your country. I'm going to choose South Africa because I'm from South Africa. And I say agree and continue. So now that I'm in here, it looks very overwhelming. There are lots of things happening. But today we just need to focus on the AI platform. So we want to scroll all the way down on this sidebar here. Scroll all the way down to where you find artificial intelligence you want to hover over AI platform, and you want to click on notebooks. So scroll all the way down to AI platform and click notebooks. And as we see, this is what they want us to do in the lab. They say launch the platform notebooks, which is going to take us to another screen. Everybody seems good to go. Great. So from this screen, which also has lots of things that I would encourage you to look at in the future, what you want to click now is New Instance. And you want to scroll down to TensorFlow 2.3. It might say 2.2 on your screen, but it should probably say 2.3. And you want to click without GPUs. We don't need a GPU today. So New Instance, TensorFlow 2.3 without GPUs. And here, you just want to say create. Don't worry about anything else, just say create. And if I go ahead of you, you can always go back to the guide on the Quick Lab where it says the same thing. It says click create. Now it says this new virtual machine will take 2 to 3 minutes to start. The other day when I did it, it took about 5 minutes. So don't worry if it doesn't work in 2 or 3 minutes. So what's going to happen now is you're going to see this here. And you've got this loading bar. It says setting up proxy to Jupyter Lab. Just wait 2 to 5 minutes until that gives an option to open up a notebook. So for now, we're just going to wait, and you can ask any questions you have. Yeah. In the meantime, those of you who want to maybe go ahead, you can try and follow these steps, continue with the lab, and I will catch up. And if you get stuck, I'll always be there to explain. Okay, what I'm going to do, maybe it's a bit silly of me, but I think it's for the best. I had to do this the other day. I'm going to end the lab for myself. I'll restart it, and I'll catch up very quickly. In the meantime, I would encourage you to try and go 1 or 2 steps ahead, just following the lab, and I will catch up very quickly. So for the rest of you, you want to click on this terminal button in Jupyter Lab. So where, for me, it's still loading, you click Open Jupyter Lab, and you're going to click on Terminal. And in Terminal, you want to run the following line of code where it says git clone da 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 da. You want to copy that onto your clipboard and put that into the terminal. And that's going to load up all of these files on the left. So you do that while I just catch up.
أي واحد عنده مشكلة ولا عنده حاجة في الفري كويك لابس أكسس دونك مادام جاي جون يكلمني على الماي نبعث له الأكسس.
Great. So what we're going to be doing, you've opened, yeah, so I hope everybody's gotten to the stage. When you say Open Jupyter Lab.
I'm sorry.
Yeah.
I'm sorry for interrupting you, but me too. It didn't work for me, but I don't know what to do.
Yeah, I think you can run through the lab again in the future. So when I first tried it, it didn't work, and then when I tried again, it did work. So then the steps are quite easy to follow. The idea today was just that we would do the steps with some explanation of what's going on. So for those, so yeah, I think you can still learn a lot just from listening in. Same with anyone who didn't sort out the credit issue. And for now, we're just going to have to follow along with the screen. So what Malik's done is he's opened up this notebook, following the instructions where it opened up a terminal, he copy and pasted that code, and now he's at the notebook. And I hope everybody's where he is. Cool. So back to the notebook. We're going to run line by line. So there's just some import at the beginning. So if you just click on that thing and click the arrow at the top, so click on where it says import OS, and then you want to click the run button. Sure, great. So that's going to import whatever you need, and then do the next one as well, the next code chunk, and that's just to create some directories. None of this is stuff I need to explain because these are just specific to the Google Cloud. And then the next code chunk, that's actually quite important. What's happening there is the data is being split into something called training data and evaluation data. The idea behind the training data is that that is what you're going to be using to train your machine learning algorithm, your neural network. And then you want to see how it performs on data it hasn't seen before. So that's what the evaluation data is. So you train on seen data and you evaluate on unseen data. So you'll run that. And then the next line of code just shows what the first few, so it says, the line of code says head. Head just shows the first few lines of this data. So remember, we were talking about census data on the population. We said it shows people's ages, their occupation, those kind of things. So if you look at it, it agrees with that. So the first line, you see somebody that was age 39. They worked for the state government. You can see things like bachelors. So they had a bachelor's degree. You can see that they were never married. You can see that they were white, male. And at the end of that, you can see that they had less than or equal to 50,000 as their income. So that is the label, less than 50,000, and the rest is information. And if you look towards the bottom of those, you see some of them have greater than 50,000. So the whole idea is that this algorithm is going to try different data. So that's what head did. So now we're going to the next step, which is to run a local training job. So the code here, the first one is just creating some files. So you can run that code. We don't need to explain it much. The first chunk that says, bash, that one, you can just run it. Then, if we look at this next bit of code, this is a bit of that data kind of preparing I was talking about as part of that data science process. So they read in the data as a CSV file, and they start labeling the columns. So you can see there's a whole thing there where it says CSV columns, age, work class, education, those kind of things. So at the bottom of that thing, it's just doing some pre-processing is what we call it. And some of those bits of data are what we call categoricals. So age is just a number, but you want to encode something like relationship, which could be husband, not in family, those kind of things. You want to encode those to numbers. So husband becomes 0, wife becomes 1, unmarried becomes 2, that sort of thing. Because the algorithm wants to work with numbers, not with labels, not with like words. Again, things like the country, things like the income bracket, those are treated as categoricals. So that bit of code that you run is just doing that. It's encoding it. The next function, if you scroll down a bit. Yeah, so the next function is also just a bit of pre-processing the data. So a CSV file is a file where all the data is comma separated. So now it's reading that file by just kind of using the commas as spaces and stuff. So don't worry too much about that. That's also just specific to this problem. So when you run this code, it's going to do all that for you. And then the next function is also just to download the data if it's not already present, but we already have the data, so we don't need to worry about that. And then the next function called preprocess is doing what we just said. It's converting integers into floating points. So things like age, which could be seen as integers, it's making floating point just because that's easier to work with. And it's converting those categoricals into encoding them, like I said as well. So education goes from bachelor's or high school to 0 and 1, that kind of thing. We can scroll down. The next thing is standardizing. And what standardizing the data means is so let's say you have a column of values for age. It could be 20, 30, 35, whatever. You want to now convert that column into a new column where the mean is 0. And the idea behind standardizing is that if you do that to all of your columns, they start looking quite similar. And when you start training your model, it's good that the data is similar rather than like some small values, some high values, because then the way that the model learns might be a bit skewed. So that thing is just going to be standardizing the data, which is what data scientists will often do, so that it's easier for the algorithm to work with it. And then the next function, which is load data, is just taking this data now that we've pre-processed all of it, and it's splitting it up into training and evaluation, like I said, but we want to distinguish between the X's and the Y's. So all of those things like age and marital status, those are the X's which we're using to try and predict Y, which is our income category. So for the training data, we want to split that into train X, train Y. And for the evaluation, we want to split that into evaluation X and evaluation Y. So all of these lines of code are doing that for us. And I really do encourage you in your own time to go through and try and understand each line of that code. But obviously, we can't explain every line of code today because that'll take a long time. So it's taking the original data file, it's splitting it up into train and test or train and evaluation, and it's pre-processing. It's doing what I said. It's turning the categoricals into numbers. It's standardizing those and so on. So we run that code. Well, we can scroll down to the rest. Cool. So that's what that whole kind of chunk did. Now, Melik, have you run that chunk of code? I assume you've run it. Cool. So now this next file, this next chunk of code is for another file called trainer model. And what this is going to actually do is it's going to create this neural network that we've been talking about today. So it's going to define the architecture for this model. So how do we take our training X's and how do we use those to try and learn Y? So all of this code is going to make use of TensorFlow to actually run a machine learning model. And like I said, all the maths and stuff that's happening behind the scenes, TensorFlow does for us. And the purpose today is to use the model rather than explain why it works. But you can trust that this function is going to take in the data set and it's going to pass it through a machine learning model. So we can scroll down a bit. So here is a good point to stop. So where this function called create keras model, this is actually the machine learning architecture we're talking about. So if you look at kind of some of the words there, it says you have a line that says dense 100, and then you have a line that says dense 75. Each of those things are what we call layers. And in machine learning, you start with your inputs, which is the standardized data we've been talking about. It's your age, your marital status, and so on. And you pass that through a bunch of layers. And each time, it's applying some functions to that information. So you see it says something about dense 100, and it says activation ReLU. That basically means that that layer has 100 nodes, and you're applying a ReLU activation function. And the next layer is 75 nodes, and you're applying a ReLU activation function. And the next is 50, and then 25. And the final one is just one node, and you're applying something called a sigmoid. And the reason you're doing that is, remember, we now want to tell, based on the input, we want to predict whether it is less than 50,000 or more than 50,000. So we just want one value, less than 50 or more than 50. And what dense is going to do is it's going to give us that one value, and the sigmoid function is going to give us a number between 0 and 1, which you can see as a probability. So you might say, if it's less than 0.5, it's less than 50. And if it's more than 0.5, it's more than 50. That's how you can see it. So the final layer of this whole network is returning a probability. And based on that probability, we're going to say, does this person have less than 50,000 income or more than 50,000? So that's what's happening with those kind of numbers and layers there. And something that you have below that, if you scroll down a bit, is it says compile model. So the most important thing there that I want you to show you is this line that says loss equals binary cross entropy. Now, if I could share my screen again, I'll show you what I mean by this. But what a loss function is when we are training our model, it's going to make a prediction. And this prediction could be wrong at first. The value could be less than 50,000, but we predict greater than 50,000. We want to now understand how wrong we were. And if we know how wrong we were, we can try and move in the direction of being more right. So imagine for a second I said it was actually 55,000, but the answer was 40,000. We know that we're 15,000 off of the target. And if we said 60,000, we know it would be 20,000 off the target. So we know where we need to be and we know where we were now. And we can do a bunch of maths to kind of work out how next time round the prediction will be closer. So next time around, the prediction could be 45,000. Yes, Melik, that's gradient descent, which is how you improve the model over time. But to start the gradient descent process, you need to know how wrong you were. And in the case of a classification problem, it's actually quite difficult to know how wrong you were. It's not just you're 15,000 off target, because all you know is that you didn't get it right. So binary cross entropy is a kind of mathematical function that tells you how wrong you are. And if you allow me to share my screen just for 1 second, I'll show you what the formula for binary cross entropy is. So I'm going to share my screen for just 1 second. And again, thank you to everyone for following on despite these conditions. It'll all be fine soon.
There is no problem, you know, this stuff happens all the time.
Thank you so much. So you can see my screen now. Here we have this maths, which is binary cross entropy. And that will tell us how wrong we are. And I don't want to spend too much time trying to get into it, but that's going to tell us how wrong we are. And based on that, we use something called gradient descent to actually improve the model. And over I'll stop sharing now. And Melik, you can come share again. But over thousands and thousands of tries or iterations of this machine learning algorithm, or even just a few dozen tries, our algorithm will get less and less wrong each time until it's as close as it can be to being correct. And that's how it learns. I haven't looked too closely at the code. I see this question about, are we using something called regulation? And I haven't looked too much at the code in this case, but that's a technique that is often used to help train your model. Yeah, and then this final bit of code we can probably just run without worrying too much about. That is just passing through our different arguments. Because what's going to happen is we want to obviously feed in our data and then apply the data to this model. So these are all just bits of code that are going to make this code robust so that we could pass in any data if we were to run it again. Yeah, so let's just run that code and then move to the next block. So this next part is step 2.2. This is running a training job locally. So he's clicked run here, and well, I assume you've clicked run, and we've got a bunch of stuff happening down here. Now, what's going on here is this is actually giving us information about how the model is training over time. So we've got these things called epochs or epochs. You can see that word there. That's kind of like a training run. And we've decided we want to do 20 training runs. And if you look along there, you see some nice bits of information. So yes, you should run every single line of code, Lila. So you see there's a value called loss. And in the first epoch, that loss was 0.48. And in the second epoch, that loss was 0.357. And in the third was 0.34. So as we went down these epochs, the loss got less. And that's what we said, right? We said that we want to get less wrong every single time. And at the same time, the accuracy got better each time. So it started at 0.79, 79.9% accuracy. But the next time, it was 0.8338, so almost 83.4% accuracy. And it got better and better. And if we look to the far right, we see something called validation accuracy. So like I said, we've split our data into training and evaluation. And often our models can learn off the training data very well, but the evaluation data is to try and see how it performs on data it hasn't seen. So usually the validation accuracy is a bit less than the training accuracy, but not always. But as we can all see, as we continue down the epochs, loss gets less and accuracy and validation accuracy get more. So Malik, if you can just scroll down to the 20th epoch, we'll see what's happening there. So by the 20th epoch, we see that the loss has gotten, it's gotten smaller and smaller, but eventually it's not changing much. And the accuracy has kind of peaked at around 85%, which is still good. Whatever we're trying to do, 85% accuracy sounds quite nice. So that's what running that has given us. So at this stage, the model is actually trained. And that means that we can now give it completely new data and see how it predicts. So let's scroll down. So now it says prepare an input for prediction. So what we want to do is we want to take a few new observations and see what this model predicts as the income, less than 50,000 or greater than 50,000. I have a question from Mohammed who says, what's the difference between loss and validation loss? So like I said, we're running this model on the training data that we've already learned it off of, but we're also running it on new evaluation data. And for each of those, we're going to get an accuracy score and a loss score. So the loss tells us how wrong we were on the training data, and the validation loss tells us how wrong we were on the evaluation data. It's just like that. So looking back at the code, we see that we have new data that we are going to try and predict off of. So if you run the line of code that says print prediction input, so this is now what, so these are 5 new people we're trying to predict off of. And you'll notice there we've got the usual things. We've got their age, we've got their marital status and all those things. But look at age. Age now is 1.12. But somebody can't be 1.12 years old. And it says minus 0.046. Somebody can't be that years old, but it's because of what we've been doing with the standardizing and the pre-processing that this is what it now looks like. Once you standardize it, it looks like that. And if you look at marital status, we see 42022. But before it was saying unmarried, married, husband, wife. So this is showing how we have encoded our data and how we have standardized it and what it looks like now. And what you'll also notice is that we don't actually have a value for prediction for income now, because remember, this is new data. We're not trying to, we don't already know what the value was. We're trying to predict it. So that's what the data looks like. So now the next few bits of code are just putting the data into a file we can read, so a JSON file. Not to worry too much about what's happening there. But now is the important thing. So now we actually want to use the model that we've built to make a prediction. So this bit of code here is going to output our prediction. Let's see what it says. It's just taking some time to run. Okay, cool. Now look at what we have here. We've got values that don't look like less than 50,000 or greater than 50,000. But what it's telling us is probabilities, like I said earlier. So we see for the first one, it says 0.099. So that's saying that that was the value between 0 and 1 that the model gave for it. And because that's less than 0.5, that would have been predicted as less than 50,000. And also 0.036. Because that's less than 0.5, that would be predicted as less than 50,000. And all of those, all 5 of those, because they're less than 0.5, it's saying that in our case, for these 5 people, we've all said that they will have less than 50,000 in income. And if we'd gotten a value greater than 0.5, so imagine one of them said 0.7, then we would have said that that person has greater than 50,000 in income. So those are the 5 predictions, but we can actually check to see if they're right. So Malik, if you can do this for me, can you create a new code chunk? If you press the plus sign, it'll create a new code chunk. And I want you to just scroll up a bit so we can find out what the variable was called. Just a bit more, a bit more, a bit more. Yes, so there's a variable called prediction targets, prediction underscore targets. Can you just print out prediction underscore targets? And what prediction underscore targets is what the values for income actually were. Okay, so we can see there that the first one said 0, the second one said 1, and the other ones were all 0. So 0 in this case means less than 50,000 in income, and 1 in this case means greater than 50,000 in income. So as you saw, all of our predictions said less than 50,000 in income, but one of them was actually greater than 50,000. So our model is good. It got 4 out of 5 right. That's 80% right, but it could have been better. So that's just so. But remember, here we were looking at unseen data, so it was bound to make at least one mistake on this data it's never before seen. But for 80% is pretty good. So that was just to show you that our model actually is making fairly good predictions, but it's not perfect, which is fine. Cool. So now we move on to step 3. And this is the kind of exciting bit where we actually run it all in the cloud and use the AI platform. So this stuff here, they actually need to make a change. So you see here in the code, it says project equals your project name. That you need to actually now change and replace with your project name. So if you run the code above it where it says bash, now look, if you run that, it's going to give you a project name. You want to copy and paste that and replace the project variable with that. This is probably the only part in the quick lab where you actually have to replace some code, because this is a unique thing. So will you just now where it says your project name, will you replace that with that code? Not in the echo, but in the chunk of code below that. So where on the next block of code it says project equals your project name, that's where you want to actually replace it with the quick labs. And remember, you want to put the quotation marks around it because it's not a number, it's a string. Great. So now run that. And everybody, I hope you also do that with your unique project name. Great. And now you want to run the next bit of code, which is going to create the environment with your project name and a bucket name and your region and all those things. And this is essentially just setting up your cloud storage buckets. It's going to give you access to some part of the cloud. And now you want to just run the next few lines of code. Now, these things aren't actually at all related to the machine learning. This is just setting up Google Cloud, which I hope you'll all learn to do in the times to come, because it's very useful. So you just want to run all those bits of code and see what the output is. And for those of you who are more interested in what's happening, you can see what the comments are. It's telling you what's happening at each stage. So while these bits are just run, there's a question from Melek. So the question is, in every iteration of the gradient, are we doing forward and back propagation? And when do we get to the local optimum we stop? Okay, I'm just going to read this quickly, and then I'll say what the question is trying to ask. Okay, cool. So the question is just explaining what this forward and back propagation process is. So in machine learning, it would have been nice if I could have shared a kind of image of what a neural network looks like. But yes, you are right as far as what you said. So we start off, right? Let's say iteration 1, epoch 1. We have all of our inputs. We pass them through some random model, and we get a prediction. We find out how wrong we are, and we use a process called backpropagation or gradient descent to make changes to this random model. So now it's not random anymore. Make changes to it so that next time we'll be less wrong. Then we try again. And we're still going to be wrong, but we will probably be less wrong. And we keep on doing that until we get to what's called a local optimum, which we hope will be a global optimum. We hope this will be the best possible kind of network. And once we've gotten to the point where we're not really getting better each time around, we stop and we then try that on testing data, which is what we've done here. So we trained our model to the point where it wasn't improving anymore. Then we tried it on some new data, and we got 4 out of 5 right, 80% accuracy, which is quite good because your testing accuracy is usually going to be lower than your training accuracy. And in this case, our training accuracy is 85%, and our testing accuracy is 80%. So that's quite decent. Back to the lab. So we've run quite a few lines of code. And now what we're doing is we're uploading our training and testing files to the cloud. So if you see the line that says export train, export eval, that's now uploading our files to the cloud, to this cloud bucket, as well as uploading the files that we've used to train and everything. So we're uploading all of that to the cloud, and then we're going to actually run it in the cloud. So at the point we are now in the lab, we're actually close to the end. So now we want to go to the checklist in the lab, and we want to click on those checks. Yep, check the progress. Yes. Yes, we've got 4 minutes left, so we've actually got to hurry up a bit, but we'll be fine. So back to the notebook. So we want to continue running these lines of code. And again, I would encourage you guys to all redo the lab again and read everything that's happening step by step. And now you want to, so you don't want to run that code yet, or I guess you can. It'll take some time. Okay, there seems to be an error, but that's just because, okay. Just make sure that you've run all the lines of code, but Pratik is saying we need to change the job ID manually. Ah, yes, there we go. So where it says your job ID, you want to get your job ID. And that is that thing there that says census and then underscore underscore. Yeah. Perfect, perfect. So you want to run that, and now we won't get that error anymore. Pratik, thank you so much for that, that assistance. So now we just run all that code. And it's not going to run immediately because it actually needs to now sync with the AI platform. Yeah, just so if you scroll up, Malik, you'll see that it's actually taking some time to cool. Yeah, it'll give you errors because I don't think it's actually loaded in the cloud yet. So only when it's registered that in the cloud will it not give you errors. So now what we should do is if you go to the AI platform, so Malik, if you can go to the AI platform tab, top left, yes. If you go to jobs, you'll see that it's actually now training on the cloud your job. And only once that's finished running can you actually run the other lines of code. So what we were doing locally, remember when it showed us all those epochs and the accuracy and the validation loss and all those things? That was training locally on that notebook. Now it's training doing the same thing but in the cloud. And then once it's trained in the cloud, we can make predictions on the cloud. And what we're going to end up seeing is that the predictions will be the same, but now we've done it on the cloud, which is cool. So it's actually very similar to what we've already done. And that's why if the lab does end here, it's not the end of the world because you've seen what the output is like. You've seen that it's going to get that 80% accuracy, or it'll be different for other people's computers. But yeah, you have to wait until job ID gives you that tick. And unfortunately, just because of the time delays we've had, it might not reach the end. But luckily, we can all do the lab again in the future. We've got a month to do it as many times as you want, as well as other labs. So while we wait, I'm happy to take any questions. Your job is done, but you're still getting the same error. Okay, well, Pratik, you can definitely follow those steps to get the month subscription. It will work. You just got to try it a few times, maybe in incognito. So you will be able to get that month subscription and do this again. The errors often come just because there might be one line of code where we should have assigned a certain variable name and we didn't. And if you read the things closely, you'll pick up. That's your error. Okay. It'd be nice if I could see the whole error message, or at least the context of that, like where in the code it was. But anyway, so because it's taking some time to run, let's actually just go back to the notebook and walk through the final steps and see what is happening there. So we deploy the model to the cloud. And once we do that, we can make a prediction. So if you just scroll down past the points where the errors are, you can, so you would be sending a request on that same data. So if you look at that next line of code, there's a test.json that would have the data on those 5 people that we had earlier, and then it would give us the results of those predictions, and that would be those 5 things where it probably would say 0 for 4 of them and 1 for one of them. I mean 0 for all of them, but then when we look at the actual data, it would say 0 for 4 of them and 1 for one of them. So it would end up having the same result, but the point is that we've done it on the cloud, which is quite cool. And then obviously the lab is finished and you can do the checks and you get the 100% completion check. Unfortunately, we couldn't finish in time, and that's mainly just due to unforeseen technical errors. But you do have a month subscription. I do encourage you to go and check it out. And Pratik, I'm sure you can sort out the subscription with the team. It should work out. But yeah, from my side, I hope you learned a lot from the first half of the session where we talked about data science and machine learning. And I hope that you did understand what was going on in the lab. And I'm sure you can go through it in your own time and just make sure you finish it off. And once you've done this lab, please continue with the quest, because by completing the quest, you'll actually get a badge for your developer profile. But yes, at this stage, I'm happy to take any questions. And then otherwise, I suppose Belhassan and the team will start closing up the meeting.
Any questions?
No, but I need to know why we export a JSON file.
That's just the file format that they wanted for this case. It doesn't have to be a JSON, but JSON is quite often used, especially when we're storing models and kind of loading up models. Because remember, a model could take weeks and weeks and weeks to train. And we want to store that somewhere. And JSON usually is the good format for that. And then you could, email that to a friend and they could load up the JSON. And I suppose they're doing the same for the data. But that's just how the lab wanted to do it. You don't have to do it in JSON. You can often just upload it as another file format, but maybe Google and the Google Cloud Platform have some standards you have to adhere to. But if you're running it locally, you can use whatever file format you want, as long as at the end of the day, it's read into Python and the data is the way it should be. Any other questions? Sure. Yes, so the Google, yeah.
Sorry. Go ahead, Jonathan.
Okay, no worries. Okay, cool. Yeah, with the Google Cloud Platform, it does have a lot of kind of standards and ways you need to put stuff in. And I think if you redo the lab and read through all that text, it'll tell you exactly why it's doing what it's doing. A lot of the lines of code we ran were just scripts to format the files and create files and make directories and stuff. That's why I glossed over a lot of it. And if we'd had more than an hour, I definitely would have tried to walk you through more of the code of the actual model. But after this, I'm sure that my slides can be uploaded. And I'm also happy to, at any stage in the future, do a talk about the actual mechanics behind machine learning and the maths and like the forward propagation, the back propagation, the gradient descent, all of that. and we can even do some cool like actual coding problems, like maybe make something that can identify cats and dogs, or make something that can identify items of clothing. It'll be fun. And Pratik, on the question of how to become a member of DSE, there are DSEs all across the world. The one in Tunisia that that you've stumbled across today is, I'm sure, a great one as well. And there are links that I'm sure Bahassan can send you to actually join the chapter. And doing that will keep you up to date about future events, and you can use the platform to register for events like for this one. But yeah, and also look around. I think you said you're from India. There should be a DSE. I mean, there are many DSEs as well in India. Join as many as possible, because they'll be doing all sorts of different events, and you'll meet all sorts of different people. It's a community, in the global community. So definitely worth joining, and it's free and it's a good time. Any other questions?
So, Jono, I wanted to express my personal gratitude for the effort and the extra time you have contributed. I very much appreciate the time you spent discussing with me the details about this study jam, and I'm willing to other collaborations with you and all the South African Google community and Google community all over the globe.
Definitely. And thank you so much for having me. As I said at the beginning of this call, I've actually just finished up my time with the DSE, but I would definitely like to connect you to the South African clubs. There's obviously the one at my University of Cape Town, and I think quite a lot of other ones have started this year across the country. And there are many benefits to the different clubs joining, collaborating. If you do an event on, let's say, Flutter, and we do an event on something like Firebase or whatever, it's always good to share the resources or co-organize events. And if you have access to experts that we don't, it's always good to put us in contact with the experts. So there'll be lots of collaboration. And yeah, I'm very impressed with the team and what you put together today, and I'm looking forward to hearing from you soon. There's some questions on the group, so I'm just going to respond to those quickly. There's a question saying, can I develop said system for Android apps or Swift apps? You definitely can. Google has a lot of ML tools. They've got an ML toolkit, which is really nice, because you can, without even having to do much programming, you can create an Android app that accesses the camera and then can identify objects through the camera. So I would definitely check out either it's an SDK or an API. Just Google funnily enough, Google the Google ML toolkit and see what you can do with it. And you can definitely integrate machine learning into an Android and Swift app, for sure. There's a question on how you can contact me. I'll put a bunch of things now. You can contact me by my Gmail. You can contact me by my mobile number. You can also connect with me on LinkedIn, and we can always chat and do whatever. It's always nice to have a global network of people. So you can just find me on LinkedIn by searching Jonathan Hart, and you'll probably find something about some student at the University of Cape Town. That's me. And yes, you can talk to me about anything. Just chatting, if you want me to speak at an event, if you want mentorship or data science advice. More than a data science student, I'm a student of life, I think. So I like knowing things and reading things, and we can always have interesting conversations. But thank you, everybody. It's been a pleasure. And good luck with the DSE, and good luck with the Google Labs. Yeah, the quick labs can be quite fun, and you've got time to do as many of them as you want. So thank you.
Thank you so much. I should have a moment to thank Malik for sharing his screen with us. You saved us, man. Aishik. And thank you everyone for being here, and thanks for everybody who has been there from the beginning. And Mr. Jonathan, or let's say Jono, as it was written on your first slide, it was a pleasure having you here with us. Thank you so much. You taught us a lot of new, interesting things. And please don't feel guilty about the technical issues, because that stuff happens all the time. And that's it. Thank you so much.
Thank you all for the help. I have final comments. I speak in Arabic, Jazz will speak in English. أول حاجة العباد اللي لقات مشكلة في البري أكسس نتاع كويك لابس. يبعثوا لي ميل يكونتاكتيني ولا يقعدوا دولة خدميت حلول المشكلة تسجلوا الإكرام حلول المشكلة. دونك أي واحد لقى مشكلة يقعد معنا يحل المشكلة. ثاني حاجة كما قال جوناثان دونك تكملوا اللاب في الدار. دونك ما خلصش باش خدمة تو بعد لا يحل المشكلة يكمل اللاب في الدار. ما تكملش اللاب بركة. فما في الكويست فما برشا أكثر من لاب. في التراك نتاع داتا ساينس فما أكثر من لاب. دونك أحسن حاجة إنكم تكملوا اللاب الكل. علاش؟ على خاطر باش تلقوا جوجل بادج الكترونيك بادج اللي تنجم تحطوه في السي في نتاعكم، تنجم تحطوه في اللينكدين اكسترا. بهذوما الحاجتين اللي حبيت نقولهم. اي واحد عنده سؤال ولا عنده مشكله في البيك كلاود ولا اي مشكله ما نلقاها يقعد معنا توا ونحلوها.
So Belhassan was saying that if you have any problem with the Quick Labs, you should contact him, and he's gonna write his Gmail in down below in the chat. And please finish the labs for to have your electronic badges. Thank you.